This is Blue Waters, a supercomputer.
Blue Waters is the largest system that's available on a university campus anywhere in the world. It takes up around 5,000 square feet. It's made up of 12 rows with 24 cabinets in every row.
Located within the National Petascale Computing Facility at the University of Illinois, Blue Waters is one of the fastest supercomputers in the world.
Blue Waters has a peak performance of 13 petaflops, which means 13 quadrillion calculations every second. One way you could think about petaflops is in terms of how long it would take a human being to do this many calculations. And if you had a calculator and started out doing one calculation every second, you would need around 31 million years to do what the supercomputer does in a single second.
Any researcher from across the country can submit a proposal to the National Science Foundation to obtain the privilege to use Blue Waters. A group of researchers here in Champaign were one of the first to experience the intensity of Blue Waters.
So he was going to talk more about Blue Waters.
Blue Waters is a computer that is about 100 times more powerful than the computers we could use before. And in the work we do on living systems, power means everything.
Klaus Schulten, a University of Illinois physics professor, and his research team are harnessing the power of one of the fastest supercomputers in the world to fight against one of the deadliest diseases, HIV.
The only pharmaceutical target that hasn't been exploited to date is the capsid.
The HIV capsid is an egg-like shell that encapsulates the viral genetic material that leads to AIDS. No one has ever been able to get a clear understanding or atomic look at the entire capsid, limiting the advancement of research in the battle of HIV.
Before, you can only study isolated parts if you wanted to, but at the end, that doesn't really tell you the whole story of what's going on. You need the whole assembly.
We need to understand this virus, which is very large, much larger in size than other viruses. And that is what exactly we could do with Blue Waters, to study the entire virus with all its million atoms. And when we put the data together in the computer, there we had this virus in front of us, atom by atom. And that was a wonderful moment.